This is Mr. Beck Does Your Homework. This is physics homework number 8 about projectiles launched at an angle. This is questions 2 and 3, a two-part problem. Question 2 says, a baseball is thrown at an angle of 23 degrees relative to the ground at a speed of 26.6 meters per second. So I know that I've got some initial velocity, and this angle, this monster, is going to be 26.6 meters per second at an angle of 23 degrees. So I know that if this is my ground, that I've got 23 degrees right here. The ball is caught 51.8834 meters from the thrower. Now, if I throw the ball up, it's not going to follow this arrow very long. It's going to fall off of that and make a parabola and come down and land over here somewhere. So this is saying that this distance from here launch to here catch is going to be 51.8834 meters from there to there. Okay? The acceleration due to gravity is 9.81 meters per second squared. How long is it in the air? Answer in units of seconds. Well, this is where I need to set up my x world and my y world. If you don't set up x world and y world, you tend to get these questions wrong. So x world is going to be everything that's happening horizontally, and y world is everything that's happening vertically. And I can separate the two because that's how physics works. In the x world, I know that my displacement is going to be 51.8834 meters. In the x world, I know that my acceleration is 0 meters per second. In my y world, I know that my acceleration is going to be negative 9.81, in this case 9.81 meters per second squared. What else do I know? I've got this 26.6 meters per second. Can I put that in the x world as a velocity or in the y world as a velocity? The answer is neither. This is the monster. The monster doesn't belong in either world. I have to take that monster of 26.6 meters per second and figure out how much of that is projected here into the x world and how much of that is projected here into the y world. This will be my initial y velocity. This will be my initial and final and all the time x velocity. So this is 23 degrees. I've got myself a right triangle here. So my x world velocity, I know that my velocity in the x world is going to be this velocity times the cosine of theta because x is adjacent. So I know that Vx is going to be V cosine theta and that Vy is going to be V sine theta because y is opposite. Then I would have an x component and a y component of this initial 26.6 velocity. So in the x world, my velocity is going to be 26.6 times the cosine of 23 degrees. And in the y world, my initial velocity is going to be 26.6 times the sine of 23. That's the initial velocity. That's the velocity over here where it takes off. So now I'm looking for time. I could go and use one of my tricks in the y world and figure out my time there, but what's neat is I've got a distance and a velocity in the x world already. So to answer this, how long is it in the air? Well, that's up and down, but that's how long it takes to go, 51.8834 meters. So I know in the x world that my velocity is my distance over my time, meters per second, or my distance is my velocity times my time, which is meters per second times seconds gives me meters. But I'm looking for time, so I'm going to rearrange this once again, and I get my time is going to be x over v. It's my distance over my velocity. So t is x divided by v, divide both sides by v. Now I've got a distance in the x world of 51.8834 meters, and I've got a velocity, which was whatever this answer was, 26.6 cosine 23. And make sure that's in degrees, and I'm going to get myself my time out of that math right there. Now, the second question says, how high is the tallest spot in the ball's path? I want the height, and I want this height right here. Now I've got to be careful. That's going to be a vertical height, so that's a y. But this time is not when that happens. This time is when it comes back and hits the ground again. It's a total time in the air. So now I just want the highest spot on the ball's path. don't think that you can use this meters per second, the 26.6, and draw some sort of triangle, because this is a distance and this is a velocity. They don't belong in the same triangle. So what I need to do is to go to my y world and say, well, how do I figure out my y at this point? I have a couple of options here. I do know the time for the total flight. I know the time here would only be half of that. So if it takes a certain amount of time to make the total flight and I'm on level ground, then it would take half the time. So I could do that. But I'm going to do something else. I'm going to get my height with my equation that says that my height is my initial velocity times time plus 1/2. Oh no, sorry, I don't want time. I could do 1/2 gt squared, but that's not going to give me, yeah, that'll give me my height, initial velocity time 1/2 gt squared. Then I could use half of my time and plug it in here. So that was my first option, using half the time. Okay, so if I use half the time, then I could plug it in there. But what's even better for me is, since I know that my final velocity up at this point, my y velocity is going to be 0. So now I can do v squared equals v0 squared plus 2gy, another one of my motion equations. My final velocity is going to be 0. My initial velocity was 26.6 times the sine of 23. Whatever that is, squared plus twice negative 9.81 times my height, y, that I'm looking for. So now it's just a matter of algebra. Solve this, move it over, divide by twice 9.81, and that will give me my y equals. And I will get a number there, and that will be my answer to question number 3. How high is the tallest spot? And that will be positive, so that'll be good.